Probability, theoretical, experimental, and compound. This is a digital lesson, and the lesson starts with some vocabulary, so you want to go through these with the students. Probability, event, outcome, theoretical probability, experimental probability, and sample space. Now, students get to slide 5. They're going to be moving these terms into the correct place in the sentence frames. So they can refer back to the 2 previous slides in order to do this. So blank is the likelihood of an event happening. That would be probability. So they're just going to click and hold on the edge of the term they want to move and place it into the correct box. It's measured by a ratio, and they're going to do that with all of the terms. Now we get to slide 6. You want to go over this with the students. This is the likelihood of an outcome. So if something's impossible, it would be at 0%. If it's certain, for sure it's going to happen, it would be at 1, which would be 100%. If it's right in the middle, equally likely, 50-50 chance, that would be 1/2 or 50% chance. If it's probably not going to happen, it might, but it's probably not, that would be unlikely. And likely means it probably will. So students are going to use these terms on the next couple of slides, next 3 slides. So here, they're given a little scenario here, and they have to type in one of the terms. So it will happen, 100% sure, that would be certain. So they're just going to type in certain. It probably won't happen, that would be unlikely. Never happen, impossible, and so on. So they're just going to type each of those in. The next slide has some actual events here. So rolling a number under 7 from a number cube. Well, all the numbers on a number cube are under 7, so it would be certain. Rolling an even number, well, half the numbers are even, half are odd, so that would be equally likely, and so on. And then on slide 9, what are the chances of getting heads when you're flipping a coin? Well, that would be equally likely. Here's one just for their amusement. The chance of your teacher dancing on the desk, well, you might get some different answers there, and so on. Then we're going to go into what we call theoretical probability. So we're going to use ratios to show the likelihood that something will happen. So we have a bag of 20 marbles. There are 6 blue, 4 red, 2 yellow, 5 green, and 3 purple. If we just take a random sample, that means we're just choosing by chance of 1 marble from the bag. What is the theoretical probability of choosing a red marble? Well, they're going to answer each one of these questions. So how many marbles are there total? So they're going to type in 20. How many are red? Well, they're going to type in 4. And the ratio is red to total. So we want to switch those numbers. 4 red, 20 total. And we want to simplify this ratio just like we would simplify a fraction. So the theoretical probability would be 1 to 5. And we're going to do this with the next slide. So here we have a bag of marbles, some different amounts of different colors. I want to make sure the answer is simplified. What are the chances of choosing a blue? Well, there are 5 blue and 20 total, but we need to simplify that. So if we divide the numerator and denominator by 1, just like with fractions, we would get 1 to 4. And they're going to do that with other colors here. When they get down to this one, chances of choosing a green or a yellow. Well, there's 2 greens and 4 yellows, so there's 6 chances out of 20. And if we simplify that, we get 3 to 10. Now we've got experimental probability. Now this is the actual results of an experiment. So here we have a student who had a bag of M&Ms, and he or she chose from the bag 10 times. And this is what they got. So they got 1 brown, so the experimental probability was 1 out of 20. They got 2 blues, which would be 2 out of 20, and we're going to simplify that to 1 out of 10. There are 4 greens, so that would be 4 out of 20 or 1 out of 5, and then 3 reds. So this is the actual results when they did the experiment, the results of experimental probability. Now on the next slide, we're going to talk about theoretical versus experimental probability. Now they may not have the same results, but if they repeat the experiment several times, the answers should be close. So each time they repeated an experiment, it's called a trial. And students are going to use a number cube on the next slide. And if you don't have any number cubes for the students, there is a template. The students can cut it out and glue it together so that they have their own number cube. And here they're going to roll their number cube 24 times, and they're just going to tally how many times they received each of these numbers. So here, 1, 1, 1, 1. Let's say they got a 1 4 times. Maybe they got a 2 1 time. They got a 4 twice. And again, they're going to roll 24 times, and they're just going to tally each of these. Now here, the experimental probability, here we have 4 out of 24. If I simplify that, I get 1 out of 6. And you can see on this one that it's exactly the same as the theoretical probability. They're not all going to be the same, but they should be close. So this one, 2, how many times did they roll a 2? Well, they only rolled it 1 time, so 1 out of 20. That one's not quite as close. So the students will be able to compare the difference between the experimental probability and the theoretical probability when they do the actual experiment. Compound probability, then, is the probability of 2 or more independent events occurring together. So let's say you have a coin and a number cube. You flip the coin and you roll the number cube. What are the chances that you're going to roll a 5 and flip heads? So we call this a compound probability. We're just going to multiply the probability of one event by the probability of the second event. So the chances of rolling a 6 would be 1 out of 6. The chances of flipping heads would be 1 out of 2. And if we multiply those together, we get the compound probability of 1 out of 12. Students are going to do this on the next slide. So let's say there are flipping a coin and rolling a number cube. What are the chances of rolling a 2 or a 3 and flipping tails? So the chances of rolling a 2 or a 3 would be 2 out of 6, which would be 1 out of 3. Flipping tails, of course, would be 1 out of 2, 50-50 chance. And we're going to multiply those together to get the compound probability of 1 out of 6. And they're going to do the same thing with the next one. They get down to slide 17. Again, we have some sentence frames. They're going to move these into the correct place. And then there's a little challenge for students who need a little bit more. We have a deck of playing cards, and students are going to find the compound probability of choosing a heart and rolling a 2 on a number cube. So that is a digital lesson of probability, theoretical, experimental, and compound.